Hello, Algebra 2. This is lesson 4.6, the fundamental theorem of algebra. The essential question I want you to have in mind is how can you determine whether a polynomial has imaginary solutions? Okay, so let's start off here at the beginning. The table shows several polynomial equations and their solutions included repeated solutions. So we kind of talked about that in the last couple of sections. Notice that for the last equation, the repeated solution, x equals -1 is counted twice. So when you're looking at this, notice that this is linear. It has an exponent of 1. It has a degree of 1, and the number of solutions is 1. Okay? This is quadratic. The degree is 2, exponent of 2, obviously. It has 2 solutions. This is cubic. It has a degree of 3, an exponent of 3, and that has 3 solutions. Once again, a degree of 3, because it has an exponent of 3, and it has 3 solutions. So basically, the fundamental theorem of algebra says that a polynomial of degree n, as long as n is bigger than 0, the equation f of x equals 0 has at least one solution in the set of complex numbers, but the corollary to that says that it has exactly n solutions, provided each solution is repeated twice, is counted as 2 solutions. So for instance, if you had -1, -1, -1, -1, that's technically 4 solutions, so that'd be a quartic. Okay, so these are super quick and super easy. How many solutions does this equation have? Well, since it is cubic, you would literally just say 3 solutions. How many solutions does this have is the same thing as how many zeros. Okay, just like solving. How many zeros does this have? Well, it is a degree of 4, so it has 4 solutions. That is how simple those problems are. Okay? Okay, of course it's going to get tougher than that. Example 2 says find all the zeros. So what I want you to do is, first of all, notice that we have x to the 5th. So that means that there's going to be a total of 5 solutions. Now, this doesn't necessarily mean that they're going to have 5 different solutions. Once again, remember, -1 could be a solution twice. 2 could be a solution twice. Also, imaginary numbers could also be a solution as well. And when we use our graph, so we're going to plug this in our calculator, and when you use your calculator, remember we find our zeros by looking at how many times it crosses the x-axis. Now remember, if it's imaginary, it's not going to cross the x-axis, so those won't show up on a graph. So we have to do a little bit of work to get those. Okay, so I plugged this into my y equals, make sure everything else is cleared out of there. And then you're going to go up and you're going to hit graph. Now notice, when it bounces, okay, so there's a bounce there, that means that it's a solution an even number of times. And since it doesn't bounce and get flat, we know that -1 is a solution twice. We also know that 2 is a solution, but -1, -1, and 2 does not add up to 5 total solutions. So what I do is I say, okay, based off of the graph, I know that -1, -1, and 2 are all solutions. Okay, so we know that based off of the graph. We're using our graphing calculator to help us out there. Now with that, notice that we need a total of 5 solutions. So that means that there are 2 other solutions that we can't see based off of the graph. So they're probably imaginary. Okay, so what you're going to do is you're going to figure out what each of these factors are, or zeros are, by using synthetic division. So I want you to make note that there is a 0, x to the 4th. So we always want to make sure that we've got all the place values. So x to the 5th, 4th, 3rd, 2nd, 1st, constant. We are ready to go. So let's just use one of these -1s here. So we've got -1. You're going to use synthetic division. Once again, you should get a remainder of 0. So put the coefficients down 1, and then you've got x to the fourth, which is 0. We've got a 1, a -2, a -12, a -8. And you're going to want to write small because there's a lot of writing in this example. Okay, so going through our synthetic division, if you don't have this down by now, you hopefully for sure will by the end of this lesson. So bring the 1 down. Now, every time you bring the number below that line, you got to multiply by the number outside here. -1 times 1 is -1. And then remember, you got to add. So -1. Now multiply by the -1 outside. I'm going to quit writing these arrows because I really hope that as long as you're watching all these videos, you understand what's going on. So -1 times -1 is +1. When you add them together, you get 2. Now take 2 times -1. That's -2. Add them together, you get -4. Multiply -4 by -1 and you get 4. Add those together, you should get -8. When you multiply that by -1, you get 8, which is awesome because when you add -8 plus 8, you get a remainder of 0, which is exactly what should happen. And I know that it happens because it crossed or touched the x-axis at -1. So now, what you're going to do is, remember, this is your constant. This is x squared, x cubed, x to the fourth. Now we technically don't need to use that because you can't factor an x to the fourth. So we're going to continue on, okay? We had a -1. Now let's use another -1. So we've got a second -1. So we're going to do that again, but we're going to use the most previous equation. So you've got basically 1x to the fourth, -1x cubed, 2 plus 2x squared minus 4x minus 8. But we don't have to write that out because we're just going to use that again. We had another solution of -1. So let's continue to use this. So just use those coefficients which we got from the previous problem. There are no place values that need to be put in. If there were, it would have showed up. Okay, now we're bringing the 1 down. So we've got 1 times -1 is -1, -2, -2 times -1 is 2, add those together, 4 times -1 is -4, we've got -8 times -1, once again is another 8, giving us a remainder of 0. Okay, so now we've got our constant or our number, our x squared, x cubed. Ooh, x cubed is still not so nice to factor. So what we're going to do is we're going to do this all over again. So now our other solution based off of our graph was 2. So now let's go through the process. We're going to factor out that 2, or sorry, the x minus 2. So you're going to use, once again, that most recent. There's no reason to write out the x cubed, x squared, x. So let's write the coefficients. Okay, now we're taking out an x minus 2, or technically this 2 here. So we had the solutions of -1, -1, and 2 based off of our graph. So we've got 1 multiplied by 2 is 2. We get a 0 here. And then 0 times 2 is 0 plus 4 is 4. 4 times 2 is 8, obviously giving us a remainder of 0, which we know that it worked because we got a 0 there, and that's exactly what should happen. Now go through, this is your constant, this is your x, and this is your x squared. So when you are writing this, you've got x squared, we don't have an x, that's 0, plus 4. Now, so far, we have our solutions of -1, -1, 2, and now we can get our solution based off of this. Okay, so we don't have anything else to check. It didn't cross the graph anywhere. So let's set this equal to 0 and let's solve. So you can't factor this, but what you can do is you can subtract 4 on each side. You get x squared equals -4. Now I'm really hoping you remember what to do here. X squared, to get rid of that, you square root. So you have x squared equals the square root of -4. Now the square root of 4 is 2, but because it's negative, sorry, I should have showed that. Actually, what I should have showed is that it's just an x. Okay, we have the square root of negative 4. Remember, when you take the square root, you not only get a positive 2i because of the square root of the negative, but you also get a negative 2i. Okay, so we've got solutions of 2i, negative 2, 2, negative 1, and negative 1. So let's count. Let's write all those out and let's count. X is equal to negative 1, negative 1, 2. And then we have our imaginary of 2i and negative 2i. 1, 2, 3, 4, 5. We were supposed to have 5 solutions, and we found all of those. So find all the zeros. We are done.